Hello friends, this video on metal and non-metal part 16 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 15. So let's do the refining of the metals. As I told, the metals which we get are not pure, right? They have impurities, and the method that is used to refine the metal is electrolytic refining. We'll explain this, what is this electrolytic refining, but this is the one that is used to refine the metals. We'll explain the electrolytic refining method. So if you see, many metals like copper, zinc and this are refined electrolytically. We'll tell you how. In this process, a impure metal is made anode. So if you see, this is anode, this is cathode, right? So this guy is my impure and this guy is pure. So I'm assuming it's a copper, right? Impure metal, this is impure copper which has impurities in it, and this is a pure, this is very thin strip of metal, very thin, and this is actually thick. This is thick. I should have made this guy as bigger actually. It's okay. So there's a very thin strip of pure and very thick strip of impure metal, pure at cathode and impure at anode. And then a solution is used of metal salts. Since it is copper, so I'll use copper sulfate. So I'll use copper sulfate, CuSO4. Right? So this is a copper sulfate solution in this. Is used as electrolyte. On passing the electricity, the pure metal from anode dissolves into electrolyte and then it goes to the copper. Right? And also the equivalent amount of metal goes to this copper and the impurities settle down. I'll explain how it is done. So if you see, this guy has copper. So the moment I have my copper sulfate solution, it will have copper plus ion. Correct? So copper plus ion this guy have, more copper plus ion this guy will have. So since it is a copper sulfate solution, it will have a lot of copper ions. Now what will happen is, see, if you see, the flow of electron is in this direction, right? This is the direction of flow of electron. So here electrons will be there. So it will have electrons here, electrons here. So this copper from copper sulfate ion will join this guy. It will become copper. Copper plus an electron will become copper and it will add to this thing. So it will add to this. So more and more copper will add to this, right? Because also in this I have copper. Copper wants to lose electron, right? So, and flow of electron is in this direction. So copper will lose electron in this and becomes copper plus and will go to the solution. And the mud and all, the mud impurities will be here. It will go down because that mud will not become copper plus, right? So if you see, the mud and other elements will fall down, and the copper thing, when it lose electron, the electron flows now from here, right? Electron flows from here. Copper plus will be part of the copper sulfate solution, and from here, this, now we have more copper in this copper sulfate solution. Since we have more copper in the copper sulfate solution, we have this electrons here in this cathode, this free electrons. The copper will get attracted toward this free electrons, right? It's a negative, it's a positive, and then it will merge with the free electron and deposit it in this copper plate. So gradually what will happen is, gradually if you see, this will get over. This will not be there. This will get diminished and this guy will get more copper. Like this, it will get thicker, it will get thicker, it will get thicker, it will get more and copper, and this guy will get diminished. This guy will get diminished completely, right? So this guy will get thicker. What is happening is, the copper in this is losing an electron because the electron is flowing from here, right? Is losing an electron to become copper plus ion, and the guy is going in the copper sulfate solution, right? This is becoming part of copper sulfate solution, and then this copper plus is getting attracted towards its negative side, right? Because there is free electrons here, and then it merges with the negative electrons to become copper. Correct? Now is the question time. Define the term gangue, mineral and ore. As we have told that mineral is nothing but a national state. In national state you get metals, right? And they get in combined state also. Ore is a subset of minerals from where you can extract the metals profitably, and gangue is the impurities in the ore. correct? So it is like this. You have this mineral. Some of the mineral is ore, and inside the ore you have gangue actually. So inside ore contains gangue, and some of the minerals are ore. Not all the minerals are ores. Name two metals which are found in free state. So we know that gold, silver, and platinum, these are found in free state in the nature. What is the chemical process is used in obtaining a metal from its oxide? So we use reduction. Reduction is used to obtain metal from its oxide. So sometimes carbon is used as reducing agent. Sometimes other metals are used. In that case we use displacement reaction. And sometimes we used it is achieved the oxidation. I mean, from oxide we get the metal from electrolysis. I mean, using electrolysis we get this metal. So for the first case, for example, I have zinc oxide. You add carbon to it, right? And you reduce, carbon is used as reducing agent here. You get zinc plus carbon monoxide. This is the metal you have got. This is the first case. Second case, we use displacement reaction. For example, you have MnO2. You react with aluminum. You get Mn plus Al2O3 plus hydrogen. Sorry, heat you get. So we can balance this. We can make it Al2O3. We can make it 4, 3, and 2, 3. This is a balanced reaction. The third case, I use electrolysis, where I use this electric current and break that oxygen get deposited somewhere else, and my metal gets deposited somewhere else, right? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.